Hi everyone, today we're going to cover topic 9.7, coupled reactions. So often in nature, there's a lot of reactions that do not occur together. And so what nature does is it couples a thermodynamically unfavorable reaction with a thermodynamically favorable reaction. So that essentially what this does is that the overall reaction is favorable. This principle essentially operates similar to Hess's law in that you can add delta G's together such that the overall delta G naught is less than 0. This will make the entire process favorable. Oftentimes this happens in biology as an example. And so one common example of this is ATP. So ATP plus water will make ADP plus a phosphate ion. And Pi is just an inorganic phosphate ion. Oftentimes what our body does is it uses this process in tandem with other processes like cellular respiration, where essentially we'll turn the oxygen that we breathe in into CO2. It'll use this process with that in order for the reactions in our body to actually occur. And so a couple of reactions are just multiple reactions happening together to produce an overall reaction. We'll see this a lot more throughout the rest of this unit when we talk about electrolytic cells, where we often have two different reactions happening at the same time to power a battery. There's just one big stipulation with this, and that is that both reactions need a common intermediate. So for example, if I have one reaction of A plus B makes C, my second reaction needs some amount of C in that reaction. If it does not, then you can't couple these reactions together. You need a common intermediate. In this case, it's whatever C is. Here's just one actual example of it. Zinc sulfide can decompose to make zinc as well as sulfur. But you can also have, and you can see this delta G is really positive. And so this is unfavorable in the forward direction. So this reaction isn't going to naturally happen. But a similar reaction is you can take the sulfur and react it with oxygen to make SO2. And this is very favorable. This reaction wants to happen. This top reaction does not want to happen. So if you perform these reactions together, you'll essentially get an overall reaction, which we can add together just like Hess's law. We get zinc sulfide plus O2 gas. We'll make zinc solid plus SO2 gas. And what essentially happens here is my sulfurs cancel out. And as a result of this, I can just add together my delta G's. And so my delta G naught, after I add these together, will be negative 101.8 kilojoules. And so on its own, this is very unfavorable. But together, the whole process is favorable. And so the reaction occurs. So let's look at this one example problem from AP Classroom together. We're told that in a blast furnace, the reaction represented above occurs. We can take two iron oxide, which is rust, react it with carbon to make iron and CO2. And so it says the reaction is thermodynamically favorable, therefore delta G is less than 0. And based on coupling the two reactions represented below, we have iron oxide decomposing into iron and oxygen, and then carbon and oxygen reacting to make CO2. And it says, which of the following identifies a limitation in how the representations above describe the system of the coupled reaction? In other words, what am I missing is what this is asking. What am I missing? So the first one says none of the equations are balanced, but you can clearly see that in the top one I have 3 carbon, and I make 3 CO2, and here I have 3 O2. But I don't have O2 in my above reaction. And so to balance this, all I really need to do is just multiply this reaction by 3. And so A isn't really a limitation because we can just balance the reaction. B says the values for delta S in the reaction are not shown, but this is unimportant. We don't need delta S in order to look at a coupled reaction. We need delta G, and so that's not important. C says the values of delta G for the reaction are not shown. We are told that it's thermodynamically favorable, so we know the entire thing is this, but we don't know delta G for these two, and so we're definitely missing that. And so D here, let's look at this one next to see if this is true or false, says the coupled reactions lack a common intermediate species. And so if we look, again, I said that in our reactions we need something that's in common, and we can see here that in both reactions we have O2. And so D can't be possible because we do have a common intermediate species. And in reality, the thing that we're missing here is delta G. If we're coupling reactions together, we need delta G's for each of these reactions, and so that's the limitation in our reaction. We'll go over this a little bit more in class, but for now that's all. Thanks, guys.